Welcome to our channel, Neuron is all you need. So in this session, I'm going to go through agentic design pattern, which is ReAct, stands for Reason plus Act, which is a popular framework supported by LangChain and other tool frameworks. Before delving into the ReAct framework, let me recall what an LLM is. So we all know LLM large language model, which takes input as text, could be a question, anything, and then outputs text as answer, one token at a time. These are the old LLM models, which are mainly the engines for GPT, Claude, and other chart-based AI applications. The two main limitations of LLM are reasoning and action, which is decision making. Reasoning. So when you ask a question or when you ask LLM to solve a mathematical equation, it directly jumps to the final answer. It cannot give the reasoning as to how it has arrived at that answer, the final answer. Even if you ask any common question, it jumps to the final answer right away. So there is no reasoning or any other reasoning explained in the answer itself. So this is one limitation. Another limitation is LLM also cannot make decisions. It is incapable of decision making, right? And then these two are the major limitations. And the scientists have done research from these two perspectives. One is reasoning point of view, another is decision making perspective. So those are the two lines of research that happen in parallel. One set of scientists focused on reasoning, the language model for reasoning. And out of many reasoning techniques, one popular technique called chain of thought prompting. So in the standard prompting, you mention a question and answer followed by another question. Essentially, this is a few short example. So in the example, you're trying to teach LLM, this is the answer for this question. So also provide answer for this question. In these examples, the LLM has failed, the answer is wrong, sometimes it hallucinates. Then comes up with the chain of thought prompting technique. You feed the LLM with one question and a proper explanation of the answer. So this is the reasoning step involved in the answer itself. This acts as a teaching strategy to the LLM. So LLM understand the pattern from this example and try to incorporate the same pattern, and while answering this question, it arrives at the reasoning steps by following this pattern, reasoning pattern. Then the answer is right. So this is from the paper Chain of Thought Prompting. So we can go through this paper. Chain of thought prompting elicits reasoning in large language models. I'm not going through the entire paper, but this is the one research that happened from reasoning perspective, so to solve one limitation of LLM. So there are other techniques, other papers also. One is large language models are zero-shot reasoners. So this is a very strategic paper where he explains. They say that the reasoning is embedded in LLM itself, because while pre-training the LLM, large language model, the data that has examples, right? So in the examples itself, the reasoning is inherent in the LLM. So you don't need to give a prompt like COT prompt. You can simply say, give a question and say a hint, let us think step by step. So this becomes the prompt to LLM. By looking at this, let us think step by step, the LLM understands and it performs the reasoning. So this is one research happened that is called zero-shot COT. So there is no chain of thought involved examples, just zero-shot. There are other research from different papers. I'm not going through all the papers. you can go through these reasoning papers, text and patterns for effective chain of thought it takes to become. So for all these research, the chain of thought prompting is the mother, the parent of all this research, right? And then, yeah, this is one aspect that is addressed. Another aspect is language model for decision making. So if you look at decision making, there is one research paper on WebGPT. So essentially, when you ask LLM a question, so LLM, let's say in certain sense, certain context, LLM has to go through a web browser and perform some search and try to extract the content from the web page, and then consolidate or reconcile the text from the web page. And if it finds a link, it has to click that link, go to that link, navigate to that link, extract whatever the text that is interest for this question. So gather all those answers and then reconcile before giving the final answer. So this is one capability of LLM. So during this process, LLM has to make a decisions when to search, when to navigate, when to click the link, when to scroll up, scroll down. So that's the challenge of decision making. So these WebGPT researchers, they have addressed this by a concept called human cloning a human behavior. Let's say human has given a question. The way human does, first he searches, go to the Google or Bing search engine, then gets some answer, clicked on the link on the web page, then maybe he can do Control F and then gather the text, probably scroll down and scroll up, and go to the top. So these are the steps that involved while arriving or while searching an answer for a question. This is from the human. So this becomes the data set for the large language model to clone this behavior, right? To clone this human behavior. And then the LLM can be capable of answering any such questions, and then it knows when to search a web page, when to scroll down, when to extract the text from the pages. That way, we are giving an ability to make decisions into the LLM itself. And we can also give rewards to the LLM while training through reinforcement learning. But the challenging is that you need human involvement, human feedback. That is another challenge. You can check this page, WebGPT, browser-assisted question answering with human feedback. So the disadvantage is that you need to have a data set as well as the behavioral data collection is challenged, and then look at the answer. This is one training I mentioned is behavioral cloning. Another training, reward modeling. You can also give rewards. You give some 4 or 5 answers. Out of the 4 or 5 answers, you choose the best answer. If LLM chooses the best answer, you give a reward to the LLM. So that way LLM is getting trained to make the decision making. So there are other research papers, Blender bot. This is a GPT model, conversational AI. Other models, I'm not going through all the papers, but these are the research that happened from decision making perspective. So these are the 2 lines of research. And this decision making, the disadvantage, limitation of this approach is that it doesn't have a reasoning mechanism. It goes to the steps, but it doesn't explain why it took the decision, right? And this is reasoning. Reasoning cannot make decisions. So these 2 are the challenges. So essentially here, the old LLMs are like a black box models, and they are not capable of reason and then decision making. Then comes this ReAct paper, Reason plus Act, which tries to combine both best of the worlds, right? Best of the 2 worlds. One is reasoning and then is decision making, which is action based. So this is agentic design pattern, where we'll go through this agentic design pattern, how the ReAct pattern works, and we'll go through an example, right? We'll also go through a simple example. If you give a question like a prompt, I am flying Hyderabad to Mumbai next week. What is the weather like? What are my travel options and time? And what is the current USD to INR rate, so I can estimate hotel cost? So this is a proper question. How the ReAct framework resolves this question? How as to when it makes the reasoning, when it makes the decision, as to what actions that needs to takes place. So I'll try to explain this in the next session. For this session, we'll stop here.